about the news today, and then we'll have a short Q&A if you have questions. So I will leave it to Omer.
Thank you, Caroline. Thank you, everybody, for coming. First of all, welcome to the 53rd Paris Air Show. So welcome in. We at Eviation are uniquely excited to have you join us here for the rollout of the Eviation Alice just here behind us. I think it was, actually I think it's a line of a song that says, you can have an airplane flying if you'll bring your blue skies back. So we hope this plane can do both. It's an airplane flying, and we hope it will bring the blue skies back. The Eviation Alice is the first all-electric commuter aircraft in the world, and it's out here ready and waiting. It's the pinnacle of a lot of work by many partners and crew that I will talk about soon. But it's also the manifestation of some vision. And I'm glad to say that that vision has been shared with us by a client. And this is basically the reason we've asked you in. So our announcement today is that Cape Air, the world's largest general aviation commuter fleet operator, working mostly in the east coast of the US, is going to be the first client of the Eviation Alice, and will usher in a double-digit size fleet of Alices to operation. Sorry?
What airline? Sorry.
Cape Air. Cape Air. He will usher in a double-digit size fleet of Alices within the next 5 years. This is a very, very significant moment for us, not only because we can roll out the plane and tell you about a client, but also, and maybe mostly, because we see Cape Air as a very, very significant client because of his identity. Cape Air as a company has been invested in sustainability since conception. They've been focused on creating profitable models for operating general aviation fleets and have risen to be the largest general aviation fleet operator on the planet. This is why it was important for us to talk about. This is why we wanted them in, and also because they can really support with the MROs and with the experience and with everything that's needed to put forward that infrastructure to have a successful launch of the plane. Now, for those of you who do not know us as a company, Eviation was founded back in 2015 by myself and my good friend and partner, Aviv Tzidon. And we were at the time mostly considered delusional, I'll give you that. But we were thinking one thing. We want to change the way people travel. And we want to build a new plane to make it happen. Not a small feat as it is. In 2017, we were here with a technology demonstrator, unfortunately promising that in 2019 we'll be here with a full-scale functioning aircraft. So again, considered delusional at the time, we had to go back and work. That work and the very, very long-standing dedication of our team and of our partners has created the Alice. The Eviation Alice is a 9-seat, 2-crew, all-electric commuter. It flies 650 miles on a charge. It flies at 240 knots at 10,000 feet. And it will charge an hour in the air just by staying half an hour on the ground. So 1-to-2 ratio, but the other way from what you're thinking. This aircraft is not some future maybe. It's not waiting for some development in battery technology or in lightweight materials. It's there. It's right here behind us. It's operational. When some of you will meet me inside, we'll move the stick. It works. And if we look at the way we've got here, we have to mention the complexity of building a machine like this, and we have to mention our partners. So the aircraft behind me has been built over the last 2.5 years with the help of no less than 164 suppliers from 21 different countries. And I will name them one by one now. Got you, right? But I do need to reflect and to say really thank you for a few. I want to start with Honeywell, that from the very beginning jumped in headfirst, created not only the lightest and we think the best flight control computer we can use, but they gave us the opportunity not just to make this the first all-electric commuter ever built, but also to make this the first Part 23 certified fly-by-wire computer, all fly-by-wire. I want to go then to Siemens, that has been supporting us with their motors and inverters literally from the conception of the company, from starting 2015. And then to magniX, that came in and created another propulsion alternative for this same motor. I want to talk about the beautiful work of Maniag Aeronautica that created a very, very different kind of landing gear system. Yes, it's a tail dragger, if that's your headline, but it's a very different tail dragger, and we'll talk about the difference in a second. I want to say thank you to Multiplast, a French group that did an amazing work in some of the structural components of this plane, but also was the major enabler for the integration process that happened here in France. And you know, some of our suppliers actually have a bit of a history to talk about. Some of them I did talk about just now. But if you think about it, the Hartzell propellers you see in the back, they're state-of-the-art, carbon fiber, pitch-controlled, anything you can hope for in a modern propeller. But Hartzell has been making these propellers for a century for the Wright brothers. They're there from the very beginning. Without those partners and many others that I did not talk about, this wouldn't have been possible. And we're very, very grateful for that. Now, this plane doesn't look like anything you've seen on the grounds here. It doesn't look like anything that flies out today. Not because, you know, it's the right design decision. Trust me, we did care about how it looks. But because this is a truly form follows function situation. This plane was built from the ground up to be electric. It's not a retrofit of anything. It is built like a plane should be built in the 21st century, at least the way we see planes being built in the 21st century. It's all composite. It has a huge battery. For lack of a better description, it's a huge battery with some plane painted on it. Our maximum takeoff weight is 6.3 metric tons, 14,000 pounds or so. The battery is just over 8,200 pounds. That's 60% of the takeoff weight. This is the way you reach those numbers I've given you in the very beginning. You redesign. You build a machine that is as efficient as possible at cruise. You build a machine that can really do a real-life job. And this really leads me to the result of that first client declaration. We believe the market for this plane is not commuter planes alone, even though it's a huge market and there's plenty to replace there. We believe it's not business travel or executive travel alone. We believe it's not anything alone. We believe it's all of us. We believe, and this was our vision from the very beginning, we believe that the way we travel regional distances is basically flawed. It takes too long. It's too dependent on your car, even if you're in a very, very well-developed country. And if you do fly, you're usually flying too many miles in the wrong direction from too big a hub. And this is what we're trying to change. And this is why, in this age of everything being the best, brightest, grandest, and never seen before, we do think this plane is important. We as a species has been walking since the dawn of time, right? Roughly 2.5 miles an hour. That defined the size of a city center. You go to work. You go to visit your family. You go to the grocery. For many thousands of years, we've domesticated the horse, went 4 times faster, roughly 10 miles an hour. And that defined the Roman road and the distance to the next village. Transportation leaps changed the way we live. Benz and Ford gave us the car roughly 4 times as fast again. 60 miles an hour, 40 miles an hour, depending on traffic. They gave us the suburb. They gave us traffic. We believe the next leap is not standing in line for 2 hours, taking your shoes off, putting them back on, and then hopping on a plane that takes you too far away. We believe the next hop in the democratization of transportation is in the form of electrification. This is why we believe that this effort, like many other efforts around the world right now, are actually the telltale signs for a third age of aviation. We've had powered flight, we've had the jet age, and we're going to have the electric age. It's not 20 years away. It's going to happen right here and right now. And we are extremely proud to be part of this here in this venue, 110 years after the first Paris Air Show. We are humbled by this event, and we are humbled by our small position in this revolution that's early enough to allow us this space, and we believe it's a revolution that's coming. I'm very, very grateful for your time, and I would love to take your questions.
Callum Jones from the Times. You mentioned the order is double digit. Can you be any more precise on the number?
If I could, I would. Sorry.
All my compliments first for actually sexy-looking airplane.
Thank you.
I did not expect that. What's the lift-to-drag ratio of a wing? It looks marvelous. I'm a glider pilot, and that's almost the same.
That's a beautiful question, Marino. Thank you. Okay, so as you can see, the plane is built very slick, and the reason is exactly what I've described. This needs to be very, very efficient at cruise. The plane lift-to-drag ratio passively is roughly 24, which is extremely high for is extremely high for planes that size and that speed. But the interesting point here, and this is again one of the big enablers of electric propulsion, putting the wingtip propellers out there really creates a reduction in induced drag, actually increasing the effective lift-to-drag ratio. So you can either count it as roughly a 10% or 7 to 10% increase in lift-to-drag, or to have, let's say, a virtual propulsive efficiency of over 100%. So the real question is, how much energy do you gain, or what's your lift-to-drag ratio? So I said the baseline is around 24. You can say we're at around 25 actively. Just one thing before that, to kind of complete the picture. It needs to be said that a lot of the design features you see in this plane, it's not a good plane that does the work, that's very cheap to operate, and it's electric. It's all that because it's electric. This would not be possible with a reciprocating engine. You cannot take the vibration, you cannot get the cooling there. It's impossible to do. But the idea has been alive since the early 80s. There are NASA articles about it. So the thing is, the enabler is electrical power. The downside of it, as you can imagine, is the battery weight, which is all over the place. And then you need to fix it by doing a good job and making everything else work right. Sir.
I'm sorry, Peter Riggers from Aviation
Yeah.
in Australia. Where would you do the flight tests?
Great question. So this plane will leave here and go to the US, where we intend to certify it with the scrutiny and support of the FAA. The first stop of the plane is in our home in Prescott, Arizona. And this is where systems, electrical, the plane are to be tested for FAA certification. Flight testing will happen probably mostly in Moses Lake up in the state of Washington with the help of Aerotech, which is the company that will support us with flight testing throughout. Sir.
Yeah, Tim Robinson, Aerospace Magazine. A couple of design feature questions. Going to the tail dragger configuration, does that pose any problems with the forward view on landing? And secondly, the tip pods and the clearance, again, crosswinds, crabbing in. Have you looked at that?
Well, yes, we have. First of all, about the angle of view for the pilot, for example. You can see those huge windows. No one really likes a greenhouse as a plane, right? So we had to do this to really get the angles right. When you sit inside, you'll notice that it's actually more generous than most. And I think the vision out is pretty well sorted out. In terms of ground clearance and crabbing, actually one of the big advantages of having both fly-by-wire and electrically propelled aircraft is that you can do a lot of trickery with the way you manage the plane. This plane could have basically differential thrust to yaw, which means we can augment, or let's say compensate, for crosswind, not just by putting your leg in and changing control surface's position, but also with differential thrust. Now, if you think about it, we can do both. You can do both differential thrust and control surface deflection, and this actually creates a clean side force. So we could again, this will be one of Aerotech's things to prove with our team. But we expect, at least in simulation, the crosswind performance that we will show will be comparable to that of a turboprop or to that of a commuter. So we're quite confident that this will do quite well. Sir?
You talked about the scrutiny and support of the FAA. Where are you in the process of actually gaining a type certificate for this aircraft? And in light of certification regime globally, do you expect changes to a system that doesn't even exist at the moment for certifying electric passenger aircraft?
Let me put it this way. First of all, in terms of our position with the FAA, we've been engaged with the FAA since mid-2018. We find the relationship there extremely fruitful. I think this is one of the specimens that the FAA wants to see happen. It's a plane. It looks like a plane. It's well designed. It has the redundancies that you want to see. It has the range that you want to see, and it has the reserve that you want to see. So in a way, we can survive and certify in today's regulatory environment. And when I call it today's regulatory environment, I mean specifically Part 23's rewrite that was accepted sometime in August 2017 by the FAA, and I think about a month later by EASA. Now, with this in mind, I will reflect on what you've just said regarding, let's say, re-scrutinizing all sorts of automated systems and things that are out kind of in the news right now. I believe that the FAA is holding a very, very high standard to anything that is reducing the workload of the flight crew, but could be dependent on pilot training. One of the reasons we've selected Cape Air as our first client is because Cape Air is very busy training its own pilots so that they can be out there with safe flights and with safe planes while continuously feeding into their ecosystem the next pilots, the next generations. We see this plane as probably one of the easiest planes to fly. It's the first fly-by-wire aircraft in this category. It is extremely well equipped. It is extremely well balanced. And we believe that it's going to be one of the simplest things to teach how to fly this plane. But we still build that training program together with our first client, Cape Air, to create really not just a successful launch, but also the confidence in our ability to really take on this entire mission. And we're doing this hand in hand with the FAA. So the approach right now is we put the systems out there. It could do better than anything else that's flying out there today. And we need to train the pilots to take full advantage of that, yes, but we are doing this. This is why you see us here and not standing on the grass in Oshkosh and saying, look guys, we have the lowest direct operating cost plane ever built, do you want one? So probably we'll get 100 orders that day, but then we have to run after 100 pilots, train them, get the spare parts, get the MROs right, get the charging solutions right. We don't want to do it this way. We want to go the path that makes this change culture, that makes this change the way we travel. So large fleets, large, let's say, operators that can really take on a mission like this, and then collaborating around ground support, charging, and pilot training.
And
Sir.
Do you expect that to change your timeline at all as far as as they go through this process? I mean, do you expect it to go longer than...
I'll treat it as a rebound. I would say we're building this program to be certified by late 2021, early 2022. Is this realistic? Well, it depends on your next accident. I'm not going to stand here and say, oh, don't worry about it. You can buy a ticket in January 2022. We're working extremely hard. We've put the program in place. We have the right people. We have the right partners to make this happen. Will this be the result of this effort? I'm going to do everything in my power, and the team's going to do everything in his power to make it happen. I do not believe that the fact that we're taking on more, in the sense of taking more responsibility to what happens to the plane after it's sold, will be a hurdle to the certification process. I think it's accepted as a responsible act by the FAA. Sir.
I have two final questions, please. Can you give us the price of this aircraft for the operator roles? And in your business plan, do you need in the next 2 years to raise new funds for your business plan?
Two difficult ones. I'll start with the second one. No, the company is fully funded all the way through certification and, let's say, embryonic production. Regarding the list price of the plane is around $4 million. Of course, very much dependent on how many charging solutions you need and what kind of spare parts package you have as planes go. But that's the list price of the plane. Sir?
A couple of questions. You mentioned Siemens and Magnix as providing the motor. Are those alternatives, or are they both in this plan?
Those are alternatives. And the way we see it today, much like you can buy a 787 with a Rolls or a GE motor, we would like the end customer to be able to choose between a Magni-X motor and a Siemens motor. One of the reasons we have kind of split that decision for now is the fact that no one has yet to certify a Part 33 electric for aviation. So we are waiting for the process to conclude. We're hoping for the winner to be, let's say we wish good luck to both sides, and the winner will be the one that we fly with in the beginning, and I suspect that there will be a secondary option because these motors matter and the way they're going to be maintained is different. So I'm guessing that we will have some sort of different economical model to the way you maintain this motor, and this is why it is a good alternative to give to the client. Now, of course, the fact that there are two competitors running towards certification together also is more beneficial to us as the integrator because we do want to have these motors up, running, and certified as early as possible.
And if I could ask a different question, this has flown, right?
No, this plane has not flown yet. It will fly in the US. That's what I was saying about Aerotech.
So it'll fly in Moses, will it fly from Prescott up to Moses Lake, or are you?
We don't have the range for that, but it will fly in Moses Lake.
And where are you intending to? This one was built in France. Is that where you're going to build these planes?
No, planes will be built in the US eventually.
Whereabouts?
Probably Prescott, Arizona. Another one?
It doesn't replace, GA, doesn't replace commuter aircraft. It's a whole new category itself. What kind of a ballpark market figure are you talking about?
I'll answer this in phases, if you will. I believe that, yes, it does replace GA in the beginning. I believe, yes, it does replace commuters in the beginning because there are operators out there with aging fleets, sometimes flying planes that are roughly 40 years old. Actually, it's not sometimes, that's the average age. So, yes, there is a need in the market there. There are roughly 40,000 active airframes around the world of that size. So there is a need in this market. And if it's a head-on replacement, this aircraft will give a very, very significant competitive advantage to its operator. The thing is, we believe that once there is a competitive advantage to someone, and we're for sure going to see competition coming up, we believe we're going to see price tags for the tickets drop. And that means we'll have more people flying shorter distances and more people flying more frequently. So the pie grows, and maybe the model of operation changes. We believe this is the second phase of what's going to really happen. Because if you look at the time it takes to cert a plane, the time it takes to kind of introduce it to market in a significant number, and the time it will take us to ramp up production, we're probably talking about a two-faceted situation. Now, to answer your question specifically, as I said, there are roughly 40,000 airframes out there, and they're being replaced at a rate of, let's say, 700 to 800 a year. So I think that's more or less the textbook definition of market failure. Sir.
Good morning, Sebastian Steinke from in Germany. What is the installed power, and could it fly on 2 engines only?
Great question. Well, Sebastian, this okay, so each motor can give roughly 260 to 270 kilowatts. So we're talking about, all in all, roughly 900 kilowatts of power, 1,200 horsepower. And to answer your specific question about 2 engines, it can actually do better. So the system with the wingtip propulsor, will actually cut off the other wingtip if you have some catastrophic event in one, so you won't have the asymmetry. This plane can not only continue flight, but it could safely continue a takeoff after V2 with only the tail. So the basic power installed is very, very high, but don't get me wrong. The efficiencies I was talking about before in the answer to Marino's question, really create the situation where we fly for the expenditure of roughly 250 kilowatt to sustain cruise. Now, this is again an example of why electric. If you were to build a machine that can exert roughly 3 times the power you're actually using for cruise, you're probably carrying too big a motor. With electrics, system to give you a bit more power for a while in an emergency situation, something you can never do with a jet. I think for the day, some of you follow up inside, and some of you will have, let's say, ongoing sessions there. So please contact Caroline to figure out who's doing what.
Name and title, please.
I don't know. Yeah, of course.
Your name and title.
Oh, Omer Bar Yochai. I'm the CEO and co-founder of the company.
CEO and what's your
Omer, O-M-E-R, B-A-R, E-R,
Yeah.
B-A-R,
VAR.
Y-O-H-A-Y.
When's your first flight expectation?
Probably later this year, or let's say latest is first quarter 2020. Thank you, guys. Thank you so much. We went Aerotech.
Congratulations.
Thank you.